So I work in fluid dynamics, and in particular molecular fluid dynamics. So in this subject we're solving fluid problems using molecular simulation. So typically we'll be solving for many, many millions of molecules, simulating very, very large data sets. And the problem with this is we need to simulate this on a supercomputer. So this will typically involve terabytes and terabytes of data generated from these very large simulations of fluid phenomena. So we have a reproducibility crisis in science. In a recent Nature survey in 2016, 69% of engineering and science research was found to be unreproducible. So what this means is people get the actual paper and cannot get the same results as the authors of the paper. This sometimes includes the authors themselves in coming back to the paper. Now in simulation and software we have the advantage that we can actually create an entire simulation that people can download. The software can be available. So in some ways we have a higher responsibility. And what this means, especially for many areas of simulation, is that we actually need to provide a better standard of open software and open and reproducible research. So the simulation sizes we have are so large that these kind of data servers that would be needed to reproduce this data are far too big and it'd be too cumbersome. In addition, lots of times the data is in a kind of proprietary or binary format that makes it very difficult to work with. In addition, even if you have the data, there's usually a complicated series of analysis that happens in order to actually get that data into a usable form for plots. So the solution I'm proposing here is that we actually create software that includes the full software that can actually reproduce the problem and the data scripts that will actually analyse that problem as well. So our typical problem, we have an academic, they produce some data from their work, and that typically will be used to create a graph that will go into a paper. That paper will be presented to the academic community who will then assess its validity and build on that work. Now, the principle behind open data is that we upload all of that work to a cloud. And on that cloud you have all of the information the academic community can also access directly and produce the graphs themselves as well as directly build on that particular work. So here's an example, and this is a simulation that I've run. It's about 300 million molecules. So typically the picture we're looking at here is the actual simulations would be uploaded and would have lots of data in the cloud, which are impractical to upload to any kind of cloud server. What we would typically present in is a summary graph or graphs of this data set, reducing it maybe from terabytes of data to a simple line plot. And in this particular case, the academic community would only then have access to the actual final result and the graphs. So this is the process shown in more detail of open research. And so typically what happens as an academic is we provide some inputs to some software. That software produces these large data sets. We then analyse it using some form of post-processing script. So these will be typically simple codes that convert the large data sets into the graphs that then go into the papers that the academic community receives. So the solution I'm proposing is we actually take the software and inputs and we bundle them up and put them on the cloud instead. We also include the post-processing scripts as well in the cloud. And what this means is the academic community then have the full set of information they need in order to produce the data themselves. They can download from the cloud a complete working inputs and software, as well as the entire code. With one click, they can produce the same graphs as your paper. And this has two clear advantages. One, as part of the review process, the academic community can actually check exactly what you've done. They can see exactly what you've done because they can download every part of that process, ensuring complete transparency. And second, and what I would say is the bigger advantage of this process, is you then have the ability to build on this software directly. People in the community now have an easy way to download with one click all of the software they need to reproduce your particular simulation, and they can directly build on it. So this is an example from my research, looking at the liquid-vapor interface. So this is quite a complicated process. We actually have to fit a surface to a set of molecular data. From that surface we then do a mapping for each of the different points, and that mapping allows us to then get the values at each location on the surface. So the key point here is that this is quite a complicated process, one that even if you had all of the data files and the software is not simple. So the solution I'm proposing is not only to make the actual software itself open source with all of the input files in order to reproduce that particular case, but also all of the post-processing scripts that allow the user to actually download the data and actually work through and analyse that. The input scripts and the post-processing scripts are made available through a permanent link online. So that's a DOI, where you can actually download all of the information associated with a particular publication and reproduce all of the figures, no matter how complicated the analysis process is. So I propose open software, easy deployment, and all input analysis files together. And these are provided as a triangle where each part is mutually supporting. And I would argue that this should become a requirement for journal acceptance. So let's start with the open software. Essentially, you have an entire history of software available on GitHub. And the actual release that's used to generate your paper is uploaded to a DOI identifier, such as Zenodo or some other persistent link online. For the easy deployment, we have to ensure that we have tests. And this would be some form of continuous integration where your software is automatically tested and ensured to be correct at every point in the deployment. We have builds which actually make the software available, and these should be available on multiple platforms, Windows, Linux, as well as Mac, and potentially platforms or containers like Docker. The final part, the input and analysis files. These inputs and the actual files should be uploaded to a DOI server as well. Something like Materials Cloud provides a service like this that you actually upload all of the required files. And these work together with the software that you download in order to produce the outputs of your simulation, and the post-processing scripts then allow you to produce the figures from the paper. So I think during the process of research, it's actually a requirement that you develop and package up all of the files you're actually using. And so during the simulation process, during the actual development of your science, you develop these files anyway. So it just becomes a change of mentality. It becomes a case that you are actually doing the process of developing and packaging up. And this has a real advantage. It means that as an academic, you're checking your work. You're thinking about the fact that this is all going to be transparent. It's going to be available. And this also becomes part of the review process. As a first step, I would say that reviewers should be insisting on this. If someone submits to a journal without actually having the files available, that should be questioned. It should be the case that in the same way that private communication has become completely unacceptable in the references, this is no longer acceptable for you to be able to actually say software available on demand. And finally, I would say that in the long term, journals should be insisting on this. Journals should not accept publications that cannot be reproduced. And so if a reviewer cannot actually show that they reproduce the work, it should not be accepted. The advantages of doing this are that more people will be able to cite your work. And not just that, because the software is available, there's a potential for a snowball effect where people can build on your work and potentially start an entire research field that builds on this particular bit of software. In addition, the process of going through and actually making your software available and open means that people check it more carefully and that you will check it more carefully. And so this means there's a better chance that you've got rid of most of the mistakes in that. And this removes the potential for embarrassing errors. In the long term, because you've made the software completely available and people can reproduce exactly that case, it rules out the possibility, not entirely, but to a large extent, of that error happening. And most importantly, it's not too much more work. As long as you do it during the process, you will actually find that it's essentially just a small amount more.